Hello again. This is Roger Koch Barr for the Bioelectricity course, Week 6, Segment 9. Let's talk about axial currents and their relation to stimulus currents. Here I have redrawn the trace for the stimulus on the left, but no stimulus on the right. So I've stimulated on the left. This is the spatial trace. You've seen it before. The green trace is for 1500 microseconds, and the brown trace is for 7,000 microseconds or 7 milliseconds. For each of these traces, let's say, where is the peak axial current, and in which direction is that current? Well, we know the answer to that from the work before. It goes as the derivative with respect to x. Not the derivative with respect to time, but the derivative with respect to x. And the current flows downhill, so there's a minus sign. So we can see that at 1.5 milliseconds, peak axial current is along about here and along about there. It's flowing to the left and the right. At 7 milliseconds, we have considerable axial current flowing to the right and also a large axial current flowing to the left. This is what we said above. I'm just repeating it here. So now let's ask, where are new action potentials being born? Well, for a new action potential to be born, so to speak, we have to have a stimulus current into tissue that is ready to excite. Where does that occur on this graph? It occurs here at 1500 to the right and at 1500 to the left, because there is a strong axial current which acts as a stimulus current to the right and to the left. At 7 milliseconds, we have a strong axial current to the right, which is stimulating tissue that has not yet been excited. There also is a substantial, not as great, but a substantial stimulus current to the left, but that is not going to create an action potential because that tissue has already been excited and it is too soon for another action potential to be created. As you know from the earlier segments, you have to have a delay there of about 10 milliseconds or so before the tissue is again ready to be excited. It just hasn't been that long. So now let's think especially out in the middle of the fiber. On the left-hand end, there is a stimulator at the site of the electrode. In the middle, there are no wires connected. Not a wire is out there in the middle. That's not so good as far as stimulation you would think. Yet, there is an action potential out there in the middle. Where is the stimulator for that segment in the middle? And of course the answer is each site is stimulating the next. So this waveform indicates a stimulus current going to the right. The stimulus for this middle site, right there, came from the currents from the action potentials on the left, which were forcing axial currents into it. It is, from the viewpoint of the cylindrical segment receiving the current, it really doesn't matter whether it's done in the way that's over here on the left with external equipment, or it's done in the way it's being done on the right from earlier excited regions. The same thing is the consequence. Current is being forced into the interior of the segment, and that serves as the stimulator. So let's think that back over again. Stimulator for a given segment can be something external or some other kind of tissue that does something to it, and in particular that injects a current into it. But if you have a string of segments, each segment serves as the stimulator for the next. Well, it actually spreads out over more than one segment at a time, but each few segments serve as the stimulator origin for the segments to their right. So that's how it keeps going. Each region providing the stimulus to the next. Each place where there are action potentials causing more action potentials in the adjacent regions. That's not too much different from the river. Lots of things happen in one place. They affect the locations that are just downstream. What happens in one point on the river affects what happens at the points near to it. Everybody knows that who just goes out and watches the river. And you know that too if you watch the fiber. Thank you for watching. Talk to you soon again.